Hi, today we're going to talk about atomic structure. Now an atom, as you may know, is the tiniest particle that retains the properties of an element. I have an element here, pure carbon. Now how can we get down to atoms? Well, you could do a thought experiment, or a Gedanken experiment, as Einstein used to say. That's an experiment that you can't actually do, but you can perform it in your mind to help you think about a concept. So here's a Gedanken experiment. Take this piece of carbon, cut it in half. And then take that half and cut it in half again. And take that half and cut it in half again. If you keep cutting it in half, eventually you'll get down to a tiny piece of carbon that retains the properties of carbon. If I cut it in half again, I don't have carbon anymore. Now that tiniest piece that retains the properties of carbon, that would be an atom of carbon. What's an atom composed of? Well, atoms have a nucleus that's positively charged. It's positively charged because it contains protons. Protons contain a positive 1 electrical charge. Now, a proton is very important for the nucleus because the proton is the single defining factor that determines the identity of the element. If you have 1 proton in your nucleus, you are a hydrogen atom. If you have 6 protons, you're a carbon atom. I don't care what else is in the nucleus, 6 protons, you are carbon. So what else is in the nucleus then? Well, nuclei often contain neutrons. Now, neutrons are not charged, as their name implies. They're neutral particles. They simply add to the mass of the atom, but they don't change the identity of the element, and that's very interesting. You can have carbon that has different masses. It's just the protons that determine the element carbon, but with different numbers of neutrons, you'll have different masses, all of them carbon. Now, that positively charged nucleus is surrounded by electrons that are negatively charged. And in the neutral atom, there's an electron for every proton in the nucleus. That is, the charges balance out, so you have neutral atoms with an equal number of protons and electrons. If I look at these atomic symbols, we give each element a symbol. And each element symbol will have a couple properties. We can give it the atomic mass, and we can give it the atomic number. The atomic number is the number of protons in the nucleus. That's what determines the identity of the element. Now, the atomic mass is the sum of that atomic number and the number of neutrons. The mass is determined by neutrons plus protons. The electrons don't really contribute to the mass because electrons are so tiny. They're about 1/2000th the mass of a proton or a neutron. Protons and neutrons have about the same mass. So atomic mass given by the sum, atomic number determining the element of the element. The atomic number we actually often don't write down with a symbol because the symbol and the atomic number are redundant information. If you know the symbol, you know the number of protons in the nucleus. If you know the number of protons in the nucleus, you know the symbol or the nature of that element. So you'll often see an element written as its symbol with the atomic mass. The atomic mass is not unique because the number of neutrons doesn't have to be unique. I can have a hydrogen with 1 proton and a hydrogen with 1 proton, 1 neutron, that's mass 2. 1 proton and 2 neutrons, that's mass 3. All of those are hydrogen, but they're different isotopes of hydrogen. They have the same number of protons, but a different number of neutrons. And we can look at the isotopes of various elements on the periodic table.